Hello everybody. In this lesson we will find out the sum of the first n terms of an arithmetic progression. In the previous videos we learned what an arithmetic progression is. We learned how to generate an arithmetic progression if the first term is given and the common difference is given. Then we learned how to find the nth term of an arithmetic progression. Now in this lesson, let us learn how to find the sum of the first n terms of the arithmetic progression. So welcome to the lesson. This is Carl Fredrik Gauss, the mathematician. When he was 10 years old, he was asked to find the sum of the first 100 numbers. The sum of the first 100 numbers. And within few seconds, he came up with the answer as 5050. People were surprised. They asked him, how did you do that? And he explained the way he did it. He took the first 100 numbers and he wrote them like this: 1 plus 2 plus 3 plus 4. And then what he did, he reversed the numbers and wrote them one below the other. And then he added the numbers term-wise. Like this, he added the two numbers, 100 plus 1, 99 plus 2, and so on, until went up to 100 plus 1. When he added these two, he observed that all the numbers, when the two terms are added together, they generate 101 100 times. If you observe that, adding the two equations, you get 101 100 times. So 2s, then what he did was, he divided 101 times 100 by 2, because there are 100 101s, and since the numbers are repeated twice, he divided by 2 and he got the sum immediately as 5050. So this is how Gauss found out the sum of the first 100 numbers. Now the question is, are the numbers 1 to 100, are they in an arithmetic progression? Yes, they are. So if we have to find out the sum of the first n numbers, can we also apply the method of Gauss to find out the sum of the n terms in an arithmetic progression? We can. So let us apply this method to find out the sum of the first n terms of an arithmetic progression. And let's see how we go about doing it. Let us find the sum of the first n terms of the arithmetic progression. So let our arithmetic progression be a plus a plus d, a plus 2d, and so on. And if we add them, let s represent the sum of the first n terms of the arithmetic progression. And we know that the nth term of an arithmetic progression is a plus n minus 1 times d. So this represents the addition of the first n terms of the arithmetic progression. Let us call that as equation 1. Now let us reverse the order of this arithmetic progression. So the nth term will become the first term. And let us label this equation as equation 2. Now when we add the two equations, what do we get? 2s will be equal to, if I add the first term of the first equation with the first term of the second equation, that means I add this, I will get 2a plus n minus 1 times d. And if I add the second term of the first equation with the second term of the second equation, what do I get? Meaning I add the second term of this with the second term of this. I get again 2a plus n minus 1 times d, and so on till n times 2a plus n minus 1 times d. Now, since there are n terms, so I will get 2s is equal to n times 2a plus n minus 1 times d. This is what I get. Therefore, S will be, now S will be n over 2 times 2a plus n minus 1 times d. So, this will be the formula to find the sum of the first n terms of an arithmetic progression. We can represent this as Sn. So, the sum of the first n terms of an arithmetic progression is n over 2 times 2a plus n minus 1 times d. So, we have got the formula. So, we know that the sum of the first n terms of an arithmetic progression is given by Sn is equal to n over 2 times 2a plus n minus 1 times d. But can I write 2a as a plus a? Then what do I get? I get S is equal to n over 2 times, instead of 2a, I write a plus a. The rest of the equation remains the same, n minus 1 times d. Now, but what is a plus n minus 1 times d? What is a plus n minus 1 times d? It is nothing but the sum of the, it is nothing but the nth term of the arithmetic progression. So, now my formula will look like S is equal to n over 2 times a, the first term, plus a n, the nth term. This can be another form of the formula. So, if I know the first term of the arithmetic progression and the nth term of the arithmetic progression and the number of terms in it, I can easily find the sum of the n terms of the arithmetic progression. Great going. Based on this, we are now ready to solve problems. Let's try this problem. Find the sum of the first 22 terms of the arithmetic progression, 8, 3, negative 2, and so on. So, do we know what's the first term? It's 8. What is the common difference d? 3 minus 8, which is negative 5. What are the number of terms given? N is equal to 22. So, we know these values. What is the formula to find the sum of n terms of an arithmetic progression? Sn is equal to n over 2 times 2a plus n minus 1 times d. This is the formula. We know all the variables, we just plug it in. So, Sn or S22 in that case is 22 over 2 times 2a, a is 8, plus n minus 1, n is 22, so 22 minus 1 times d, d is negative 5. We plugged it in, and this is pretty easy. They are just numbers. If you solve them, you will find that it is negative 979. So, the sum of the first 22 terms of this arithmetic progression is negative 979. Excellent. Keep trying. Let's try this. If the sum of the first 14 terms of an arithmetic progression is 1050 and its first term is 10, find the 20th term. So we know what is the first term of this A, which is 10. We know how many terms are there in this. N is equal to 14. We know what is the sum of these 14 terms, Sn, which is 1050 as it is given. And we know what is the formula to find the first n terms of the arithmetic sequence, arithmetic progression. So now we can easily substitute in the formula and go ahead finding out where we land up. So 1050 is equal to 14 over 2 times 2a, 2 times 10 plus n minus 1, 14 minus 1 times d. Now we don't know what d is. We need to figure that out. So if we simplify this, we get 1050 is equal to 14 over 2 is 7 times 20 plus 13d. Open the brackets. 1050 is going to be equal to 140 plus 91d. When you move 140 on the other side of the equation, so 1050 minus 140, you get 910 equal to 91d. Therefore, d will be equal to 910 divided by 91, that's 10. Now we found d. But the question is, find the 20th term. So we need to go further. What is the formula to find the nth term of an arithmetic progression? We know that it is an is equal to a plus n minus 1 times d. So in this case, we are finding the 20th term. So a20 is equal to, what was the first term given in the question? 10 plus. Now we are finding the 20th term over here. So n is 20. 20 minus 1 times, we figure out what d is, which is 10. Simplify it. So the 20th term is going to be 200. So the 20th term of this arithmetic progression is 200. Excellent work. Keep going. Keep practicing many problems, as many as you can. Only then will you get it. Let's try this. How many terms of the arithmetic progression 24, 21, 18 and so on must be taken so that their sum is 78? So we know what's the first term of the arithmetic progression over here. It's 24. What is the common difference d? It is 21 minus 24, which is minus 3. What is the sum of this arithmetic progression? 78. It's given in the question. We are supposed to find how many terms. N is equal to how much? We know what's the formula. Sn is equal to n over 2 times 2a plus n minus 1 times d. So we can plug in the variables what we know. So 78 equal to n we don't know over 2 times 24 plus n minus 1 times d, negative 3. And when you open the bracket, simplify it. 78 equal to n over 2 times 48 plus n minus 1 times negative 3. You further open the brackets, you get 78 equal to n over 2 times 51 minus 3n. Now you can simplify. 78 times 2 will give you 156 equal to 51 times n is 51n minus 3n squared. Let's move all the n's on this side of the equal sign. So what do we get? 3n squared minus 51n plus 156 equal to 0. All these three numbers are factors of 3. So dividing by 3 on both sides, dividing every term by 3, we get n squared minus 17n plus 52 equal to 0. Now this is a quadratic equation, and we have learned how to factor quadratic equation by splitting the middle term. So when you factor this quadratic equation, the factors you get are n minus 4 times n minus 13 equal to 0. Therefore, n can be equal to 4 or n can be equal to 13. So the number of terms whose sum is 78, they can be 4 terms or they can be first 13 terms. So this is how we do the problem. A bit lengthy one, but easy one. So keep going, keep practicing. Let's try this. Find the sum of the first 1000 positive integers. So let s be equal to 1 plus 2 plus 3 on and on and on till 1000. So we know the first term over here and we know the nth term over here. Remember what is the formula if we know the first term and the nth term to find the sum of the first n terms? N over 2 times a plus an. Now we know this, so s, the sum of the 1000 terms, there are 1000 terms, so n is 1000 over 2 times the first term is 1 plus the 1000th term over here is 1000. Simplify them and then you get the sum of the first 1000 terms is 500500. Very easy. Let's try this. Find the sum of the first n positive integers. So let Sn be equal to 1 plus 2 plus 3 plus on till plus enter. So we know the first term over here, which is a, and the nth term over here is n. We can substitute in the formula. What is the formula? N over 2 times a plus an. We can substitute it in this formula. So we will have Sn will be equal to n over 2 times a is 1, the first term, plus the nth term is n. So the sum of the first n positive integers is n into n plus 1 over 2. This is the formula to find the first sum of the first n positive integers. We can use this formula to find out the sum of the first n positive integers. Let's see how we can use this formula. Okay. Find the sum of the first 24 terms of the list of numbers whose nth term is given by an is equal to 3 plus 2n. So we know the nth term. Can we find out what is the first term? a1, that is a, in fact, equal to 3 plus 2 times 1, which is going to be 5. What will be, and this is the first term a, what will be the second term? a2, 3 plus 2 times 2, which is going to be 7. What will be the third term? 3 plus 2 times 3, and that's going to be 9. So now we have the list of numbers 5, 7, 9 and so on. Can you figure out what is the common difference over here? 7 minus 5 is 2. 9 minus 7 is 2. So the common difference D is 2. We are supposed to find the sum of the first 24 terms. So we are supposed to find S24 is how much? The sum of the first 24 terms. So N is 24. Do we know the first term? A? Yes, 5. Now, do we know what's the common difference? Yes. Now we can apply the formula, the sum of the first n terms, and find out what it is. We know what's the formula to find the sum of n terms. Over here in this problem, we are finding the sum of the first 24 terms. So S24 is equal to the number of terms n, 24 over 2 times 2a. What was our first term? 5 plus n, 24 minus 1 times what was the common difference? 2. Now when you simplify this, S24 is going to be 672. So the sum of the first 24 terms is 672. Good. A manufacturer of TV sets produced 600 sets in the third year and 700 sets in the seventh year. Assuming that the production increases uniformly by a fixed number, that means it's an arithmetic progression. Find the production in the first year. Let's do one by one. So we know that the production in the third year is 600. So A3, what is the formula to find the nth term? A plus the third term, 3 minus 1, 2D. So over here A3 600 equals A plus 2D. So this is in the third year. And it says in the seventh year, that means A7 is equal to A plus 7 minus 1, 6D. In the seventh year, the production was 700. So we get 700 equal to A plus 6D. Now these two form a pair of simultaneous equations which we have learned how to solve it. Let's solve them in case if you have forgotten. So we have these two equations, A plus 2D is equal to 600 and A plus 6D is equal to 700. Let's solve this by the method of elimination. So we change the signs of the lower equation. We have learned in detail all this. Plus A minus A cancels. Minus 4D is equal to minus 100. Therefore, D is going to be equal to 25. Take the D and plug it into any one of the equations. So we plug it over here. So we will get A plus 2 times 25 equal to 600. So A is going to be equal to 550. So the production of TV sets in the first year is going to be 550. So we found the first part of the question. Let's look at the second part of the question now. So find the production in the 10th year. That means A10 is equal to the first term A plus 10 minus 1, 9D. Because the formula AN is what? A plus N minus 1 times D. We know this formula. So now A10 is equal to the first term we know it's 550. We figured it out just now. Plus 9 times, what's the common difference we got? 25. So the production in the 10th year was 775. That was very easy. Now coming to the third part of the question. The total production in first 7 years. In other words, the sum of the first 7 terms. Do we know what's the formula Sn? We know that Sn is equal to n over 2 times 2a plus n minus 1 times d. We know that formula. So we need to apply that over here. So Sn is S7 is equal to n. N over here is 7. So 7 over 2 times 2 times, what was the first term? 550 plus n, which is 7. 7 minus 1 times d. What was the common difference? 25. And when you simplify all this, you get 4,375. So the total production in the first 7 years was 4,375. Once you figure out the variables, it is easy to plug it into the formula and do the simplification, and you get the answer. So that's the end of this lesson, the explanation, but not the end of practice. So I really appreciate the way you're putting your efforts in understanding the concepts of the lesson. So keep working on the problems, take up more and more problems. The more you practice, the easier it gets. So keep watching the videos, subscribe and share. Thank you.